TuneScope has the capability to record a sound. You can record a sound by going to the Sounds tab and then clicking the red record button. At this point, I can record 1, 2, 3, 1, 2, 3. I can also use a script to play the sound, so I can say play sound recording 1, 2, 3. And if I want to remember what the recording was, I can rename it so that it is the words of the utterance, like this. And now I can choose to play this. 1, 2, 3. The recording is actually a list of numbers, and that list of numbers represents the back and forth movement of the computer microphone, which is converted into an electrical signal and stored as a digitized number inside the computer. We can get a better sense of the sound by graphing its waveform. We can do that in the same way that we would graph any other object in Snap. I can create a loop that graphs the sound, and in the loop I'm just starting out with the beginning of the sound and then graphing each point so that as I go across the screen, I'm plotting the samples of the sound. I could start with the very beginning of the sound, and if I did, let's go back and set up. If I did start with the very beginning of the sound, I would have a silent period at the beginning. And I wouldn't be able to get all of the word 3 on the screen. And this is clear when I look at the sound samples up until I get to about 25,000 samples in. I'm not really getting very large numbers, but then around 25,000, I'm getting larger numbers. So I can actually start not from the very beginning, but from the 25,000 samples in, and then if I clear the screen and start over again, then it starts right at the beginning of the utterance 1. And there you can see 1, 2, and now we can see the third utterance, which is 3. Now, note that down here, I'm actually multiplying the sample. The samples are about like 0.9, 0.8. And since the screen of the stage goes from about, I think it's about 360 from minus 180 up to plus 180, so that wouldn't be very large. And in fact, if I graph it just at normal size, you're going to see that it's not very large. So let's stop that and reset it. And now let's try multiplying it by 10, which will make the waveform a little bit bigger, but still it's not very large. So now I can increase it, the height of the waveform by about 100. And then if I do that, I get a nice clean signal that's easy to see. The up and down vertical axis is related to the intensity or the loudness of the sound. And the vertical axis is time, but I can spread that out. I'm actually going, taking every 100th point. If I just took every point, then it would, if I took every point, then it would look something like this. And you can see I'm getting a great deal of detail, but I can't see enough of the image to really tell what's going on, enough of the waveform. Now if I take every 10th point, I get something, and this will be a little bit faster if I just grab a warp block. Okay, and let's reset and try it with the warp block. So now that will spread the waveform out. If I take every fifth point, it'll spread it out even more. So now I really get a lot of detail. If I take every 100th point, I don't get as much detail, but I can see the shape of the individual words better. So the degree of detail that you want may depend on what your goal is. So this shows how you can graph waveforms and get a sense of what the waveform is like for a given song or utterance.